Okay, so in this video I want to talk about what it means to divide numbers. And I'm not telling you this because I think you don't know how to divide numbers, but because I think you know how to divide numbers, I want to link how we divide numbers over to how we divide polynomials, okay? Alright, which these look very much different than numbers. Polynomial is some function of x where all the powers are positive whole numbers. You know, x squared plus 5x plus 6, that's a polynomial. X plus 2, that's a polynomial also. So you can divide those, and I'll show you why it would even be possible or make sense that you can divide them. Alright? Okay, so about division of numbers, I mean, do you see that division really just connects over to multiplication? Alright? I can say that 20 divided by 4 is equal to 5. And all that means is that, like for any kind of division, this number, if you multiply it by that one, should give you this one. Okay? Alright, so yeah, if I say 20 divided by 4 is equal to 5, that's like saying, or that's true because 20 is 4 times 5. Okay? Now I've got another example where 7 does not evenly divide 22. We'll talk about how you do that. But it's still division, right? Okay, now I thought of a note that I can tell you about. You know, why not? It's relevant to what I just showed you here. So, you know how we say that you can't divide by 0? I guess in this one very simple statement about what division is supposed to mean, I can tell you why division by 0 makes no sense. I mean, suppose you had 7 divided by 0. There's no answer to that, right? I mean, if one way you could figure that out is you could say, get your calculator, what's 7 divided by 0? And it says you cannot do that, there is no answer. But I guess the real reason there's no answer is you would have to work like this. Say that we say, well, 7 divided by 0, I don't know what it is, but maybe it's something. What would that something have to do? You know, why is 20 divided by 4 equal to 5? Well, because 4 times 5 is 20. That's why. So wouldn't it have to be that 0 divided by whatever that answer is would have to be 7? Is 0 times anything equal to 7? Is 0 times 1 7? Is 0 times 2 7? What's 0 times any number? 0. There's no way that there could ever be anything that would do that. Alright? So we could just say, well, as far as the numbers go, that's just impossible that there be an answer. Okay. So that's why we say that we don't divide by 0. Now, how do you divide like 22 by 7? You know, it's, for most people, be hard to just think about what that is. So remember, there's a whole process of division. I could say I divide 7 into 22 like this. That's how I set it up. And I try to think of what's the most number of times 7 goes into 22 without exceeding it. And that would be 3. So I choose the 3. I got to come up with the 3. Then once I choose it, 3 times 7 is 21. And then I subtract, and I get 1. Okay? Alright, now when we do that, this part right here is called the quotient, and that is the remainder. Which I'm sure you've done this before and you've heard those terms, but maybe it's been a while. Oh, this here is the divisor. Okay, so those are all the parts. Now, whenever you divide, whether it's numbers, whether it's in a minute when we divide polynomials, whenever we divide, the answer is always going to be the quotient plus the remainder over the divisor. So you could say that 22 over 7, 22 divided by 7, was 3 and 1/7. The mixed number, 3 and 1/7. What do we mean when we say 3 and 1/7? What's a mixed number? Literally, it means 3 plus 1 over 7. Okay? Alright, so there would be my answer. That's what 22 over 7 is. It will always take, when we divide, I'll take this form, Q for quotient, plus R for remainder, over D for divisor, 3 plus 3 and 1 over 7. That's how we do it. Okay? Alright, now if I wanted to, I could check this one the same way as that one. If that's really the answer, then 7 times 3 plus 1 over 7 would have to be 22. I mean, it is math, and you can check your answer. And if it really matters if you're right or wrong, why not check it? So if that's correct, and if this is the way division always works, wouldn't it have to be that 22 is equal to 7 times the number 3 plus 1 over 7? I'll put a question mark, as if I'm checking to see if I'm right. I don't know. We'll pretend like maybe we're not right. So yes, is 7 times that answer equal to 22? Well, let's see. How would you put all that together? 7 times 3, 7 times 1 over 7? What's 7 times 3? 21. What's 7 times 1 over 7? 1. What's 21 plus 1? 22. Okay, so yes, it does work. That is the answer. Not that I had any doubt, but you know, you can check it. Alright, now that's numbers. That's what we do with numbers. That's what you learn in, I don't know, grade school at some point. It's actually not so different than how we divide polynomials. Okay, so here goes. If you have to come to the situation where you divide polynomials, then there's two ways that we could do it. Long division, which we'll learn now, or synthetic division, which we'll learn later. You know, one thing at a time, alright? I won't show you both of them at the same time. Let's just focus on one, and then I'll show you the other, and then I guess from there you could just decide how you wanted to do it. But in the book and in the assignments, it talks about both of them, so I might as well mention both of them. Okay, now, how would you divide this? Well, it's really no different than how we divide that. Like, we set it up and we do things almost exactly the same way. So it's like this. I'll say, here's what we're doing. I'm going to take x plus 2. I'm going to divide it into x squared plus 5x plus 6. That's the setup, alright? And then, kind of like how I had to choose something, then multiply, and then subtract, I'll do the same thing over here. Here's how we do it. We choose something up there, so that when you multiply it by this, you'll get a match on the leading term. Okay, so what could you put up there and multiply by this to match that leading term? Where when we do this, when we write things down just so that it's neat and orderly and works predictably, we always write our polynomials in decreasing order of the exponents. Second power, first power, no power. Okay? Alright, so let's see. The thing that I would choose is x. Okay, so I'd choose that. What's x times x plus 2? Choose it. You multiply it. X squared plus 2x. Okay? So I chose. I multiply by this. I get there. Alright, now I got an analogy here. I said it's just like how we do this. We chose the 3. We multiply by the 7. And we subtracted. So I got to subtract that stuff from that. So I'm going to put in red here, I'm going to put a minus and say, well, you know, I know that, yes, when I wrote that down it had a plus, but it's, if I'm subtracting it, now it's going to be minus. So I want to make sure that I keep track of that. So I put it in red, I circled it. That's the operative sign. So now what we do is we just combine everything in the columns as they are compatible. Like, what's x squared minus x squared? 0. They cancel. was 5x minus 2x? 3x. And what's 6 plus, well, there's nothing to add to the 6. That's like 6 plus 0. I guess if you really wanted to, you'd say you got the squares, the x's, the numbers, and there must be a 0 there. So 6 plus 0, that's going to be 6. Okay. All right. Now, we repeat this procedure until we've reduced it as much as we can. So repeat it. What do I put up here to multiply by this to match that leading term, 3x? What do you put here, multiply by this to get 3x? Be a 3. Positive 3. What's 3 times all that? 3 times x is 3x. 3 times 2 is 6. And then what? We subtract. So that's going to be subtracted. And this, and what do we get if we do that? 3x minus 3x, nothing, 0. 6 minus 6, 0 also. Okay, so the remainder is 0. Now, every time, like no matter what, whether you divide numbers or you divide polynomials, the answer is the quotient, Q for the quotient, plus the remainder over the divisor. So I guess you'd say, like in keeping with that, you'd say the answer is x plus 3 plus 0, the remainder, over x plus 2. But 0 divide by anything besides 0 is going to be 0. 0 divided by 1 is 0. 0 divided by 2 is 0. 0 divided by x plus 2 is 0. So the answer is just going to be x plus 3. Okay. So there's your division. Now, that's how you go through the procedure. I have another example to practice to show you something else. But how about this? Let's check one more of these. Just to prove that, yeah, we know we're right. Even though that might look crazy and difficult, and even though you look at it and you probably don't like it, that, all right, we did it and we're correct. Let's check it and prove that we're right. What would make the answer to this, the division, equal to x plus 3? What makes 20 divided by 4 equal to 5? The fact that 4 times 5 is 20. So, in any case, yeah, it must be, if that's right, that x plus 2 times x plus 3 gives you x squared plus 5x plus 6. Let's say, is it true x squared plus 5x plus 6 is equal to x plus 2 times x plus 3? Question mark, are we right? In other words, if I take this and multiply by that, do I get that thing? Because that's how division is supposed to work. So anyway, let's see. Multiplying those out with FOIL multiplication, I will in fact get x squared plus 5x plus 6. So yes. Okay? That's the way it would have to work if that was the right answer. Alright, now let's focus now on learning this procedure. So here's another one. It looks a lot like that one, and I want it to be that way because I want to focus on practicing this with you. In fact, you could pause the video if you want to, see if you can do that the way I did up there and get the answer, see if you get it right. Okay? But I know how you set it up first. You divide x plus 5 into x squared plus 5x plus 6. Okay? So that's the setup. That's what we write down. Then you choose something so that when you multiply by this, you match the leading term there. The one with the highest power. So again, that would be x. X times x plus 5 is x squared plus 5x. Okay? Alright. And then what? You subtract. Alright. X squared minus x squared is 0. 5x minus 5x is also 0. And 6, what's under that 6? I guess technically a 0 is 6. Okay. And like that point, we're done. We can't go any further. And it no longer makes sense to say, what do you multiply x plus 5 to get a 6. That can't happen. All right. So in this one we did it in one step. This is the quotient. That's the remainder. That's the divisor. So what's the form does the answer take? Quotient plus remainder over divisor. So I'm going to get x for the quotient plus 6 over x plus 5. Okay. And that will be it. So there's my answer. I want to make a note, though, when you look at that it's always obtained from our work by that. Okay? Alright, now, so in this video, I just did the long division. I'll give you time to take that in, ask questions about it if you need to. I'm going to do the synthetic division in a separate video. Okay?